Dear student, in this class we are going to study the chi-square test for association and homogeneity. So first we look what is association. So association of attributes is defined as the degree of relationship between two or more attributes. So the association is equivalent to the correlation for variables. So correlation is for variables and association is for attributes, that is the qualitative characteristics. So likewise in correlation we have positive and negative association. So if two attributes are said to be positively associated, if the presence of one result in the presence of the other. So if you have higher qualification, higher education, your chance of employment become higher. So they are put together, they are positively correlated. So likewise, if two attributes are said to be negatively associated, if the presence of one result in the absence of the other. So when you take an immunization or vaccinate, then the chance of infection is very less. So the one presence of one results in the absence of other. So that is why we called it a negative association. Okay. Now next we define a contingency table. To find out whether two characteristics are associated or not, we have to tabulate them in a two-way contingency table, which you already have studied in your first semester classes. Have to make qualitative characteristics. So at least you have two characteristics to be considered, and you have tabulated the criteria based on the criteria into a 2 by 2 table. That 2 by 2 table is used to test the test of independence. Also, we can use the same type of classification or same type of table to test the homogeneity. Okay, now we go for Sage-Curry test of association. The Sage-Curry test of association or independence is used to determine whether there is any significant relationship between two nominal or categorical variables. That is, if you have a two character, for example, drinking habit and smoking habit, whether the drinkers will smoke or not. So, whenever you have two characteristics to be considered, whether the one is related to other, we have said that there is an association, and for that we have to check whether they are related. So for this we have to classify the data into a two-way classification, 2 by 2 classification with one character, let it be varies from 1 to R, and the other character it varies from 1 to C. So then you have a R column, R rows and C column 2 by 2 table. So in this case, what we have done our hypothesis as there is no association between the two variables, or the two variables are independent. On the other case, the alternative assumes that there are a well-defined relationship between the two variables, two attributes. So that is what the testing. H0, the two variables are independent, and H1, they are dependent or related. So in order to find out the theoretical frequencies, before that going to in details, we just go for an example first. So consider an example. 1,000 students are classified into their brilliance and community. Based on brilliance and community, brilliance has two options, B1 and B2, and the community they have three options, A1, A2, A3. So either they belong to anyone, A1 B1 or A1 B2 or A2 B1 or A2 B3. So the number of persons belonging to these 1000 persons belonging to which group is given in that table 2015 113%. These values that are given here are called the observed frequencies, or we called it as O. As in the earlier class of goodness of it is, we also know what is O, observed frequency. So here 215, 335, 325, 175, 60 and 90 are called observed frequencies. Now the next step is we wanted to calculate the theoretical frequencies. Here we do not have any distributions, so we cannot able to calculate the theoretical frequency as we done in goodness of it. So what it is theoretical frequency, how it is calculated. So first you find this the given orange color is the given frequencies, you add them. So 215 plus 135 you get it to be 350, 325 plus 175 you get it to be 500, 60 plus 90 you get should be 150, and 6 likewise you add this the row wise total. Likewise you find the row column wise total 210 plus 300 plus 90 which is 600, 140 plus 200 plus 60 which is equal to 400, and altogether you have 1000 data. So now we are going to find a the expected frequency of a particular cell. So if expected frequency of the first cell is, you get 350 into 600. So 350 is the row total, 600 is the column total of that corresponding to that cell, and multiply those and divide it with grand total n, such is 1000. So likewise you find each of the expected frequencies, each of the closure. So in the right side table, it is in yellow. We are given the result of that is 350 into 600 by 1000 will give you 210. That is 35 into 6. Likewise, 35 into 4 will give you 140 and 1. So in orange, it is the observed frequency, and in yellow, it is given to be the expected or theoretical frequencies. Okay. So this is the way we have to able to find out the theoretical frequencies of any cell. So any cell. So now we go back to the case. So the theoretical frequency of any cell Eij is defined as Ri into Cj by n, where Ri is the row total of the ith row and J is the column total of the jth column, and n is the grand total. So that we are already seen how we can find it. Okay. So once we get an observed value and the theoretical value, then we can you calculate the chi-squared value using the same formula that we have given earlier. The chi-squared equal to sigma Oij minus Eij squared by Eij squared. So, and to make a decision we have to know the calculate the chi-squared alpha value which has to be, or critical value which has to be obtained from the table, for which we request the degrees of freedom. So here the degrees of freedom is given by r minus 1 into c minus 1, and uh, where R is the number of rows that for the given contingency table, and C is the number of columns in the given contingency. So in this case R is 3 and C is 2. So degrees of freedom is 3 minus 1 into 2 minus 1, which is equal to 2. Okay. So that is the way we are going to find out the critical values, and if the critical value seems to be greater than the computed value, or the computed value is less than the critical value, whatever it may be, if chi-squared is less than or equal to chi-squared alpha, we said that the variables are independent. So we accept the h naught if chi squared less than or equal to chi squared alpha, and we reject it if chi squared greater than or equal to chi squared alpha. So rejections means the two variables has a relationship or association. Acceptance means they are independent. So the conclusion, almost every time we wanted to check whether the association, so we are like to have an association. In that case, if the chi squared calculated value should be greater than or equal to chi squared doubled value. So again go back to the problem. So we can know this how to calculate. This is the given problem. I'll already tell you how to calculate the theoretical frequencies. And once you get the theoretical frequencies, you make it as table O in which O is 215. So the first sorry, here 215 is the first cell. Observed frequency is 215 and the theoretical frequency is 210. So that is written in here 215, 210 and 135, 140. Likewise, we have written O and E. Then we find chi squared, that is O minus E all squared by E. So here 5 squared by 5 210 minus 5 squared by 140, 25 squared by 300. Likewise, we calculate for every cell. Each cell we have here 1, 2, 3, 4, 5, 6 cells. So we can have here 6 values. So corresponding to each set, we calculate chi a square, and the sum of that will give you the chi squared. Already I said that the degrees of freedom is row minus 1 into column minus 1. We have 3 rows and 2 columns, so the degrees of freedom is 2. So the degrees of freedom is 2. So 3 minus 1 into 2 minus 1. The 2 into 1, it is 2. The tabulated value for the 2 degrees of freedom is, sorry, just uh, degrees of freedom, I think 5 point something it will come. 5 point something it will come. Actually, I don't know. Since the calculated value, anyway, the calculated chi squared is greater than the tabulated value, we can conclude that there exists a association, or we reject H naught and conclude that the brilliance is related to community. So we can use a shortcut formula. This is only for 2 by 2 contingency format. So consider a table like that: A not A, B not A. If A S and A not, B S or B not, and let it the frequencies be given A, B, C, D. Then you have total is A plus B, C plus D, A plus C, B plus D, and N is A plus B plus C. In this case, you did not wanted to calculate the theoretical frequencies or of EI. Here you can directly use this formula. So this is N into, this one is N. So you can, instead of this one, you can use capital N also, N into this one, like that, A D. So you cross this one, A, you cross this like this here, A to D minus B to C. So this one A to D minus B to C all square. So N into A minus AD minus BC all square. And for the bottom one, you start from here, A plus B into, then B plus D plus C plus D plus C, then come back C plus A. So the upper one is N into cross multiply AD minus BC, and the bottom numerator terms you have got, denominator terms are, start from here A plus B into, then B plus D into D plus C into C plus A. So this is the way you can be able to calculate chi square for a 2 by 2 contingency table. So this is only for 2 by 2 contingency table. If you have the table has more than 2 rows and more than 2 columns, you can either of this you cannot, or both, we cannot able to use this formula. So this is an example uh, where this is an example where we can use the formula directly. So please check with the normal formula. You can find the expected frequencies. Then you go for. So this value is 8 per 16. You got it to be 24. Here b plus d. So this is 12 plus 14. So 26. So total it is 50. So you can use this value table. You get a plus b plus c or everything, and you 8 into 4 n, that is 50 into 8 into 14 minus 12 into 16 divided by 8 plus 12, 12 plus 14 plus into 14 plus 16 plus 16 plus 8. So that is given here. So what we got is 0.857, and chi square. So it's a 2 by 2 table. So the degrees of freedom is 2 minus 1 into 2 minus 1. So 1. And from the table you get it to be 3.14841. So the calculated value is less than, since the calculated chi squared is less than chi squared alpha, test is not secant. So we accept H naught and conclude that the vaccination is not, but vaccination is not effective. Okay. So you can have another other examples which is given into the PowerPoint that is presented here. So this is example 3. Here it is directly calculated. I don't go for so many steps. I directly calculated it. And what problem is that as in the test of goodness of it, where we can have an expected frequency is less than 4, then what we are doing is we are adding to the adjacent number. There it is adjacent classes or the numbers. But here also the same rule is applicable. Here also we wanted to have the theoretical frequency should be greater than 4. So for the this column, the theoretical frequency corresponding to the last cell in the first row is 3.75. And similarly the theoretical frequency corresponding to the last cell of the last column is also 4. So this represent that it has a theoretical frequency less than 4. So you have to add this with, either you can add by this one is added to this one, and this one is added to this one, or that is the first row and second row should be added, third row and fourth row should be added, or instead of that, other way is to add the second and third column. So that what is I have done is add the second and third column. So I have the resulting one is like this, and with the based on this I calculate the calculated value. Okay, I observed value and theoretical values are given. Then I wanted to calculate OI minus EI squared by EI, which is chi squared, and the sum of this will give you the chi squared value. Okay, so it is turned to be 1.508. So again we have here 4 rows and 2 columns. So the degrees of freedom is 4 minus 1 into 2 minus 1. So that is 4. And the table value is 9.49. So degrees of freedom is 4. Degrees of freedom is 9.49. And again 9 now what we got is 1.508, which is less than 9.45. So we reject we accept H naught and conclude that the performance in students is independent of the college. So that does not depend on the college. So next, finally, we go for the chi-square test of homogeneity. So I already said that whether if you have a two populations and with a set of data which is classified into two groups, and we wanted to touch in the test of homogeneity is whether they are come from the same population or same they have alike characteristics. So characteristics of the populations are same or not. So simply in other way, before going to that, in whatever the null hypothesis is, the population proportion are same. So in here we have to check whether the P1 equal to P2. For P1 equal to P2, when n is large, we have already studied the normal test in our test of proportion. Here for the binomial distribution, here we go for it for a further population. We have a k populations and we wanted to check whether P1 equal to P2 equal to etc. Pk, and they are not. Some of at least one of them is not equal. Pi not equal to Pk for at least one, maybe more than one, but at least one should not be equal to 0. So again, so that is what the chi-square test of homogeneity. So it is an extension of proportion test that we have already studied based on the normal sample or Z test in the earlier. When here we are test the proportion, two binomial proportion P1 equal to P2 for the proportion from two populations are same or not. Here we have to check whether the population of K populations are same or not. So that is the chi-square test of homogeneity is done in the same way as that of test of independence. So no difference in the case. Uh, only thing we have k set of population. So that is classes. First one class set classes 1, 2, 3, etc. R, and then we have k sets 1, 2, etc. K. So here we wanted to test the hypothesis P1 and P2. Here also you have to calculate the column total, row total, then based on, and grand total, then based on which you can get the uh, expected frequencies, which is R into C by N, as done in the earlier cases of test of independence. And the degrees of freedom is again the same, R minus 1 into C minus 1, the number of rows minus 1 into the number of columns minus 1 of the table, given table. Okay, now we have an example. So we have P1, P2, P3. We wanted to check whether H naught P1 equal to P2 equal to P3. Again, at least one of them are not equal. So maybe P1 not equal to P2, or P2 not equal to P3, or P1 not equal to P3. Anyone or all. It's not compulsory that only one, but we may have all, or some of any of 2 or any of k. So that's not problem. So here at least one you should have not equality, inequality exists. So that's what we are going to check. So this is the frequency that are given. Observe not that here it is 4, but it's not the problem. It's a observed frequency, not the theoretical frequency. So once you calculate the theoretical frequency, though the observed frequency is 4, the theoretical frequency is 5.91. So we need not want it to add it to the next column. So here, whatever this given in yellow, if this frequency is less than 4, then you have to add. Otherwise, you have to keep it as such. So calculate the chi-square value as early case. So here it's okay. 5.9, how you got is 17 into 33 divided by 95. So 17 into 33 divided by 9. 17 is the row total, 33 is the column total, and 95 is the kernel. Similarly, for the second cell, it is 17 into 32 by 95. Here it is 17 into 30 by 95, Likewise, 25 into 30 by 95 goes on like that. You get the expected frequency, which is presented in yellow. So you just write OE and then calculate chi squared 1 OI minus EI squared, and some of these are given you give you the chi squared value. Okay, so here you have 4 minus 1 into 3 minus 1, 4 rows and 3 columns. So your degrees of freedom is 6, and from the table this tabulated value, critical value or tabulated value for chi-squared is 12.598. So which is chi-squared 11.228 is less than 12.59. So we accept the hypothesis and conclude that the process is identical, P1 equal to P2 equal to P3. Okay, so this much is about the chi-square test of independence and homogeneity. So we will have do the problems on live classes. Okay, thank you for this, and this will end your 99% portion, and you have one more case to be considered, that is the here you have taken P1 equal to P2 equal to P3 in homogeneous, etc. Pk, likewise we have a test for ANOVA one way analysis of variance, where we test the hypothesis that H naught mu1 equal to mu2 equal to mu3 equal to etc. mu k. So the equality of k population, which is remind for your next class. Thank you.